Hello all, my name is Krishnayak and welcome to my YouTube channel. So guys, today in this particular video, we'll see how we can actually develop LSTM models for univariate time series forecasting. Now, many of you had asked this particular question that Krish, please create videos regarding time series forecasting. So considering that request guys, and I have already explained you about LSTM, we are going to also create some LSTM models for univariate time series forecasting. Now, before going ahead with respect to this video, guys, I really want to give a quick shout out to Jason Brownie and his amazing blogs in machine learning mastery. Trust me, guys, I have learned a lot from the blogs that are provided by Jason Brownie. And I'd also suggest you, many of you basically ask me which all blogs should we refer, right? This is one of the most important blogs that you should refer because you will be getting a lot of information, a lot of very nice information from this particular blog regarding machine learning or deep learning. So the link will be given in the description. And again, thank you, Jason Brownie, for this amazing contribution to the data science community. So let's go ahead and try to see that how we can actually do this. Now, before going ahead, guys, let me just quickly go and show you what is the problem statement that we are going to solve. So the problem statement over here is that we are going to do a univariate time series forecasting. Okay. Now, suppose I have a company and I'm just taking as an example. And suppose there is a company and on the first day, it has made this much sales. Okay, in the second day, it has made this much sales. In the third day, this much, fourth day, this much, fifth day, this much, sixth day, this much, seventh day, this much, eighth day, this much, ninth day, this much. And you may be thinking, okay, Krish, why it is not reducing? Why it is always going into the positive direction? It may also have negative directions, right? It may also have some less number of values, right? So you may be thinking, Krish, why you're just taking these values? Because this just seems to be increasing as we go ahead. So, but just by common sense, we can actually see that yes, in the future also it will increase. It's okay, guys. You just take your own example, try to reduce this particular value, and also see. It's just randomly. I've just selected it. It is up to you wish that how you want to select this particular value. Now, my problem statement is that considering the previous 3 days set, okay, or considering the previous 4-day sales or 3 day, let me just take 3-day sales, I need to predict the next day. Okay, so if I consider over here, guys, I'll just write it down. This is my first day. This is my first day. Okay, just a second. Okay, this is my first day. This is my second day. This is my third day. This is my fourth day. This is my fifth day. This is my sixth day, seventh day, eighth day, and ninth day. So what I have to do is that I have to do the prediction for my 10th day, right? Considering the previous 3 values. Okay, considering the previous 3 values, I have to do it. Similarly, once I get my 10-day output, I similarly have to do for my 11th day. And here now I have to suppose my 10-day output I've got somewhere around like 224. Suppose I've just taken an example. Now for the 11th day, what I have to do is that I have to again take the previous 3 values and try to compute it. So similarly, we will be doing continuously like this for the next 10 days, so something like this up till the next 10 days, that is up to the 20th day. So this is what is my problem statement. Now, first step that I really want to discuss about over here is basically the data pre-processing. Okay, how we have to keep our independent and dependent feature. As I told you guys, if I just consider this is my x-axis, okay. Now, if I'm saying that my previous timestamp, I'm just going to consider 3 timestamps. So this will be my T1 timestamp, this will be my T2 timestamp, this will be my T3 timestamp. Now, I also have to create my independent. So X is my independent features. And here you have Y is my dependent feature. So I also have to create my Y value over here, which is my output. Now, how I will be actually creating it. Now, understand, guys. Suppose this is my data set. Initially, I have first 10 days values or 9 days value. Okay, how we have to divide this? Suppose let me consider 1110, 125, 133. As my first independent features. So I have 110, 125, 133. Okay, so this is my first record. Okay, Now, if I consider my output y, this should be my 4th day output. Okay, so this is basically my first record. Remember, guys, this is my first record. If I just select this and press a tab, oops, okay, so shift, let me just select this whole and press shift tab. So this is my first record. Okay, this is my first record, where my first record independent features are 110, 125, 123. That basically means on my 4th day, this is my output. So this is how I'm going to prepare my output. Now, I mean the first record of the data set. Now in my second record, I will now start with 125, because understand, I need to now predict 158, right? And for this, I have to use this past 3 days data, right? So I have 125, 133, 146, and then finally my output will actually be 158, right? Similarly, what I'll do, I'll just go next step. Now it will become something like 133, 146, 158, and finally my output will actually be 172. So like this, we will continue making all the data. Okay, so similarly, if I just go like this and I go on doing this, so my last record, you understand that my last output is 210, right? So considering this, my 210 output will be looking like this. So suppose this is my 210, okay, and if I see, this is my value as 196, this is my value as 187, and this is my value as 172. So I have all these particular values, guys, and this will be my last record. But still, I have to compute the 10th day. For the 10th day, my input for the data will be, right? For the data will be 187, 196, and 210, right? Now, this value, I don't have it, right? So this is how we are going to do the data pre-processing. So how many number of days we have, and trust me, guys, for every time series problem, we have to make, or we have to pre-process our data in such a way that we'll be able to create our x and y value, that is our independent and dependent features, based on the number of time steps that you have taken. So I have taken over 3 time steps. I've told that based on previous 3 dates, I have to actually calculate. Now, similarly, once I get this value for the 10th day, that what I'm going to do, I'm going to take this 3 as my independent features, then I'm going to compute for the 11th day, and I'm going to do it similarly in that particular way. After doing data pre-processing, guys, I'm going to apply my LSTM model, a simple LSTM model, simple LSTM RNN model. Because understand, these all are sequences data, so RNN will be definitely helpful, right? So after calculating, after doing that, then I'll be predicting for the future 10 days, and finally we will be plotting this. So these are the steps that I'm going to show you in this particular video, what all we are doing, and we'll go one by one. Okay, so let's go ahead. Now, first of all, this is the code. The code is actually given in the GitHub. Every information is over there itself. Now, what we have to do is that, let me just expand this and make it a little bit zoomed in so that you'll be able to see it properly. Okay, perfect. Now, the first thing that I'm going to do is that I'm going to import some of the libraries. And remember, guys, this I'm working currently in TensorFlow 2.0. If you're not working in TensorFlow 2.0, you can remove this TensorFlow, but the whole implementation is in Keras. In TensorFlow greater than 2.0, the Keras is integrated within the TensorFlow itself, right? So let's go ahead and try to see this. So first of all, I'm going to import all the libraries that are required, like sequential, LSTM, dense, and flatten. I'm also going to import NumPy. Now, let's go ahead with my data. So I have my time series data, which is same values that I've actually shown you over there. Okay. I'm going to choose the number of timestamps. Number of timestamps basically means that I told you, this is my timestamps. I told you based on the timestamps, I have to pre-process my data, right? So here again, I have taken 3, and you can select your own value. You can select 4, 5, 6, any number of values that you want. Okay. Then you can see that I'm preparing my independent and dependent features from this particular function. Now in this function takes our time series data, all the time series data, and my number of features, that is 3. Okay. Now when this is done, we'll go inside this particular function. So this is my function over here. I have my time series data. I have my number of features. So you can see number of features is 3. So here I'm going to initialize x and y, which will be in the form of list. Then I'm saying for I in range, length of time series data. So I'm just going to see, I'm going to iterate through all the elements in the time series data. And then I'm going to say that for the first time, based on the number of features, just try to find out the end point, end value. Okay. Now, suppose in this particular case, when I'm iterating through this, right? So my end value will be something like this, right? So what I'll do, I will be taking all this particular value in x-axis, and this particular value I'll be taking in my y. So that is what I'm doing over here. So you can see that I'm checking whether end value is greater than length of time series data minus 1. If it is greater, that basically means it has reached the end of this list. I'll come out by the break statement. Otherwise, what I'll do, I told you that from time series data, from I is equal to end of x. So that basically means from this particular value till here, I'll be taking that and I'll be storing it in my sequence x value. Similarly, from time series only for the end underscore ix. End underscore ix basically means that for the first iteration, this will be 0 plus number of features is nothing but 3, right? So third index, you can say. So which is the third index? 0, 1, 2, 3, right? So this is the index. This will get stored in the y-axis for the first time. Okay, so that is once done. And similarly, this will be happening for all the data inside this time series. And finally, you'll be able to see that I'm appending that in my x and y value. And then I'm returning this array of x and y. Just try to execute by your own, guys. You will definitely be able to understand this. This is pretty much simple, because if you understood this logic, the code is pretty much simple. So I've explained you in this particular manner how we are actually doing the data pre-processing. Now I'll execute this quickly. So after executing, let me print x and y. So this is my x values. Okay, this is my y values. This basically means that for this x, this is my output y. For this value, this record, this is my output. For this record, this is my output. For this record, this is my output. Similarly, I'm doing all these things. Now, let us see that what is the x dot shape. X dot shape is nothing but 6, 3. Obviously, it should be 6, 3 because I have 3 features and 6 records. 6 records has been created. Now, this is a pretty important step, guys. Understand from this 2, when I see x dot shape, right? This is nothing but the number of records. This is basically the number of timestamps. So timestamps is pretty much important over here. Okay, and always remember, whenever you are implementing LSTM, you always have to reshape your data into a 3 dimensions. How? What all 3 dimensions are required? One is the number of records. The second one is with the shape of this particular, like how many number of time steps are there. And one should be something like n underscore features. Okay, so n underscore features, don't get confused by this timestamp and this features, guys. Okay, timestamps I'm considering just like a features over here, but this features is just something different, where we are just trying to convert this shape into a 3-dimensional shape. If you want to convert this, we just have to use 1 over here, so that it becomes 6 cross 3 cross 1. Okay, the same number of element has been just been converted from a 2-dimensional into a 3-dimensional. Okay, so that is what this step is done, and this is pretty much important. You can see over here, reshape from sample underscore timestamps into sample underscore timestamps underscore features. Okay, so just like this kind of example is given over here for you, but just understand this reshape is pretty much important. Okay, we are just trying to convert this 2-dimension to a 3-dimension, so that we will be able to give this as an input to our LST. Okay, and this is pretty much important. Now, the next step after we do this, if I execute this one, guys, you will be able to see that. Okay, let me just see the x shape. Now you can see that x shape is 6, 3, 1. Pretty much simple. Now let's go ahead and try to define or build a LSTM model. This is pretty much simple, guys. I hope everybody knows this. Initially, I'm creating a sequential layer, then I'm adding a LSTM layer. Activation is ReLU, because again, I'll tell you, ReLU works pretty much well with LSTM. The return sequence is equal to true. Here is the most important thing now. Okay, guys, this is pretty much important. In the input shape, we have to give n underscore steps and n underscore feature. If I try to see what is the n underscore steps, this is basically the 3 value based on the number of time steps. Or I can also say this as number of time steps. And this is basically what we have actually done with respect to the 3-dimensional conversion, right? The last feature which we require, we have to give that as an input shape into our LSTM. Okay. So guys, in the next layer, again, I'm adding an LSTM layer of 50 hidden neurons, and here I'm applying an activation function as relu. And finally, this is my output node, or the neural network node, basically, where I'm keeping the value as 1, so that we'll just need one output. Then we are doing model.compile, optimizer is equal to Adam, and loss is equal to mean squared error. Finally, let us do it for 100 epochs and try to see. Just let me increase it to 300 epochs and let me quickly fit the model over here. So we will be fitting the model. Let's see, we'll face any errors or not, or it will just get executed quickly. Yes, it has got executed quickly. If you really want to see verbose with verbose is equal to 1, you'll be able to see all the epochs, that how it is basically taking place. And here you can see all the epochs. So quickly, and since the data set is very, very small, guys, and the execution time will be very, very less. Okay, so this, once my fit is done, okay, now this is the most important step. Okay, guys, so the next step is that I'm going to predict for the next 10 days after I have actually fitted my model. Now, this step is pretty much important. What I'm going to do, as I've shown you my data set already, for the 10-day computation, I will be taking the previous 3 days data. Okay, so previous 3 days data I'll be taking over here, and then I will be computing the 10-day output. After getting the 10-day output, I will again append this to my input so that I can compute my 11th day. So for that, I have written this particular logic. This will be happening for 10 days. Okay, there are 2 statements, if and else. First loop, it will go to the else block, because we already have the 3 days input, right? In this particular block, as soon as it goes, we are basically adding, suppose we are, once the output is got, we will be appending in this particular list, and then we'll be taking this last 3 values to calculate the next value. So similarly, we'll be going on. I would suggest just go through this logic. I have written this particular logic to get the output. Okay, so you will be also able to see that I'm printing the values also over here, like what is the first day input, what is the second day output, what is the first day output, and all like this, right? So I'm printing this. I would suggest, guys, this is a very interesting logic that I have written. Just go through this and you'll be able to understand. But understand the logic is something like this. Okay, suppose this is my 9th day output, right? I will append this over here to my input, and it will start from 186 like this. And then I'll compute the next day output. Then again, I'll be taking this particular value. This will become my input, and again I'll compute the output. Then again I'll be taking this 3 as my input. So that is what this if and else logic will actually do. Okay, so let me just execute and show it to you. So here you'll be seeing that, okay, the first day input is 196, 210, 222, right? So this is my first day input. If you really want to see the first day input, then what I'm going to do after this is that, remember, I have given this as my first day, right? 187, 196, 210. If I go and see in the else block, I have printed y hat of 0. So this is basically my output, first day output. Now what I've done, I have appended this over here inside my list. And you can see that I skipped this 187, right? So it is starting from 196, 210, 222. Then for this, I will be getting this particular output. Then what I'm doing, again, I'm appending this to this particular list, and it is starting from 210 till this particular value. Again, I'm getting the output as 247. Again, in the next day, my input will be looking something like this. You can see that it is clearly given in front of you what are the output I'm getting for a specific day, and for the next day input, that is actually added at the last. And remember, always the size of this will be 3 timestamp. Okay, 3 timestamp, and again we'll be getting 1 output. Again, I'm adding this 271 over here inside this particular list, and again I'm taking it from 247. So like this, it will continue. This is all my final output for the next 10 days. Okay, this particular list, and this particular list is actually stored in list underscore output. Now what I'm going to do, this is my time series data. This is the length. I'm going to create some date for this. Okay, so first I'll create the date of 9 days, right? So this data that we had, right, the whole data that if I show you, this whole data was for 9 days, right? So I'm just going to create the date for those data, just like day 1, day 2, day 3. So here I've just written np.arrange 1, 10. Then I've written the prediction data is from 10th to 28th day, right? So 2 days pattern I've written, and I've just plotted day, new with time series data. This was my data set that I had. and day underscore pred, which is basically my predicted data set from 10 to 20, and I'm plotting it with my list output. Now, once I execute this, you'll be seeing this amazing results, right? Now here you can see that this is my data that I had, and this is the data that is being forecasted by the LSTM, right? Isn't it amazing? I know you'll be thinking that, Krish, the data will always not be like this. Yes, the data is not always like this, and you cannot just here you can also see that, right? After some point it is coming down, it is going up, it is coming up and going down, right? So similarly, this is just done some kind of predictions which is pretty much similar to this kind of line, right? So this is how we have done this particular visual analysis, about the visual analysis of the time forecasting. And this is how we can actually easily develop an LSTM model for univariate time series forecasting. Now, probably this is pretty much good, because now we can take the time series forecasting of stock prices, of Google stock prices, of Microsoft stock prices, and we can actually implement LSTM RNN and see that how it will be doing the prediction. So I hope you like this particular video, guys. In the next video, I will be coming up with more different kind of multivariate time series forecasting also. So many of you had also requested to come up with multivariate time series forecasting. That also I'll be explaining you. All this particular code will be given in the GitHub that is provided in the description, guys. I hope you like this particular video. Please do subscribe the channel if you have not already subscribed. I'll see you all in the next video. Thank you, one and all. Bye bye.